Right, next we have introducing CogniFlow, a framework for automated analytical data processing and monitoring pipelines with LADS OPC UA, and ASM as a practical interoperability use case. Presenting this is Ricardo Cunha, right? Who's a researcher and project manager with IUTA. He's got a background, holds a master's in biochemical engineering and a PhD in environmental engineering, and has quite an extensive background in both academic and professional environmental technology with relevant interdisciplinary applications that have been implemented in various projects, excuse me. And so with that, I'd like to invite Ricardo.
All right. Considering the kind of like the time lost, I would kind of make it a little bit snappier. I think it will be recorded, so it can be then followed up afterwards if there's any interest on this. I'm just introducing a project named CogniFlow, which we started this year, actually, more or less. And this is a cooperation between us, IUTA, and the University of Duisburg-Essen. And to start, I would like to actually bring the problem to the front. And in this book, which was edited by my colleague, Dr. Tutterberg, we described the laboratory of the future, where we highlighted many challenges that we have in terms of digitalization, automation, and really to make the best out of the data that we have. So at IUTA, we are a non-profit organization. We do research, but we also provided services in the fields of pharmacy, but also environmental technology, but also connected to monitoring of wastewater, surface water. Of course, there's a lot of data collected from these kind of like from these sites. And the main issue that we face these days is when you look, for example, at the simple wastewater treatment plant, you not only have chemical analysis, but you also have biological analysis, you have sensor data that ultimately for a technician, which is mostly then responsible for the wastewater treatment plant, is completely unreachable to handle all of these data streams. So currently, it's mostly paper-based, even some of these parameters being recorded, and there is barely any data processing or data storage infrastructure on these places. So the idea for us was to tackle a little bit that. So how can we streamline not only data standardization but also data processing to enable this kind of more applied entities to have better data management. So as I said, we, IUTA, are cooperating with Duisburg University in Duisburg-Essen, and we have also as associated partners Ruhrverband and LINEC, and they are central laboratories that are responsible for the monitoring of different wastewater treatment plants. So mostly we are developing this in cooperation with the praxis to kind of make sure that what we do is meaningful. The idea here is, of course, to develop a software, and the idea of us starting with ontology, I don't think I need to explain why that's important. I think it's very much agreed that that's a good start to actually define what we want to do in the first place. And the idea of CogniFlow is really to enable to deploy algorithms towards developing data processing pipelines to standardize the way that we collect, process, and store data. Of course, the focus on these will be on wastewater monitoring. That's the scope of the project, and is also what we see the most demand for these kind of approaches. Looking at the framework that we would like to use, that was one of the interesting kind of conclusions we decided to go for, because when you look at the available tools to do this, you can go anywhere, but Python would be one of the most acceptable, let's say, in terms of deployment in not only like mostly in governmental institutions that that would be kind of compliant. So we stick with Python, but the problem is that we don't want to kind of keep these as a static project. We want to expand it. We want to enable developers to contribute to it. Ourselves, we are mostly developing ourselves algorithms to enable data processing for analytical data. So we don't want to have these statics. And the way that Python builds up, it's that you always depend on the package that you are using. So meaning that at the end of the day, you have like a very complex dependency network that really kind of challenges the expansion. What we are talking about, the expansion in processing capabilities, like adding a new algorithm for, I don't know, peak finding in mass spectrometry, or a new way of correcting the baseline in Raman spectra. And this expansion we solved with looking at kind of like abstracting the way that we want to implement this. Is like when you have like a factory that produces a good, you have then these wholesalers that will kind of just distribute the goods, but the consumer at the end will never kind of interact with the factory itself. It just looks at the retailers. So this is exactly what we would like to implement in this case. So we have services providing algorithms as sort of contracts that then are resolved in different places within already predefined packages, that then the consumers, they don't really need to know where the service comes from, but just interact with the resolver, which allows us to scale quite well the processing capabilities at a given installation of the software. Of course, like to enable all of these, there's this ontology and semantic layer that we have implemented, so that everything is traceable in terms of meaning. Meaning that what we are looking into specifically, like let's say that a concrete example, let's say that you have an OPC UA reader as a service. So this as a contract, and this contract is then resolved towards a use case. In this case, this can be used by the pipeline manager, which is the backend of running a specific pipeline where this step is being implemented, or you can just use it in a graphical user interface. So the place for these consumer packages is the resolver, not the service providers, which means that we can very quickly expand the platform. So the graphical user interface was something that we kind of are trying to give priority, because the resistance to code, it's very much a reality as we go to praxis. So without a UI, you barely cannot really promote any of these standardization in terms of data processing. Those scripts won't work. So in this case, we were trying to build a very simplistic pipeline towards interacting with data processing. So in this case, you have like this node-like approach, similar to Cunha, similar to very other kind of tools that are already there available. But our focus is, as I said, like try to standardize, meaning that once you have these nodes, so a specific algorithm, here you see a very simplistic average. You do have that representation, and there's kind of like a meaning behind it, which is then defined by the ontology. Once you have like all of the nodes, you construct a pipeline which goes from the input to the output. It's completely defined by the ontology. The actual export file is NQ files, where everything is described as is used in the pipeline as it was developed. And as I said, like the main key point here is that once you develop like this step, there's kind of an algorithm behind which does not interact with this node. What this node sees is the service provider for that particular step, which is then calling that algorithm in the backend. The meaning of all the parameters, in this case, the outputs, is, as I said, defining an ontology. And for that, we also have embedded in the software itself, like the wiki for the ontology that we have created within the package. So we are new to this ontology, so definitely not something that I even learned in the university. So it's fairly new, but we are trying to follow all the guidelines, reference already existing ontologies like the AFO in some places as much as possible. But the idea is that we have like this knowledge that we can reuse not only for documentation, but also for intrinsic validation of what we are doing in terms of connecting different processing steps together. As I said, the level of data literacy and competences from research, which is what we are doing, to the practice, it's very wide. So the idea here is that we have algorithms we mostly deployed as C++ code. They have like this definition based on the ontology on top of them, representation on the UI, and ultimately you have then the pipeline, which then can be applied by the end user. In this case, a wastewater treatment plant, for example, has a pipeline which just collects all the sensor data, harmonize the sensor data and deploy it in a database. So that can just be one pipeline where this data is being stored. That can be then taken up by someone else in a more standard way. So this ODEA project was something that I started with my partner in this project, which is Ricardo. And in this initiative, we are kind of like trying to teach kind of like algorithm development as well as kind of validation. And this just builds on top of that. So in this ODEA project, we'll find hopefully soon CogniFlow and all the other projects that we have been developing. Our associated partners is where we actually will test these on the real use case scenarios. So these are working laboratories monitoring over 100 wastewater treatment plants. So there's already a lot of data. But we hope that we can solve this problem. But to solve this problem, this is what we need. And this is the use case that I would like to bring along. So we need to have interoperable communication towards collecting the data and standardization on transferring these data. So in this case, what we are focusing on is on OPC UA connectivity, so that we have like the seamless connection to an instrument or to a source of data. And from these, we have structured data coming out as a standard as well. In this case, ASM, it's a very interesting alternative for these. So within CogniFlow, we are exploring the OPC UA as a client using, at the moment, we are using async UA. We would like also to have this ability to use the C library. And then regarding the ASM, what we have done so far was just a C++ reading and writer, because we do plan to have some writing mostly on the results side, in specifically concrete results. In this case, it's the actual description of a peak for high resolution mass spectrometry. We are kind of working on that at the moment to create like a full description of what we are using, what kind of terms we're using. But the idea here is that we have a way of reading this ASM in a standard way and then use the data within to deploy in these processing pipelines. So that was all in a nutshell. I hope I can save some time with this. And if you are interested, please contact us, have a look at the ODEA project, and we'll have more information there. And yeah, thank you.
Thank you, Ricardo.